Greetings all. Today we have a small equation here. This is a logarithms again, and we have to solve for x. Natural log of x minus 2 plus natural log of x plus 1 is equal to natural log of 3 times x minus 5. So it's a simple one, but good for exercise. So if we reproduce it here, we apply the first rule of log a times log a plus log b is log a times b. So we say natural log of x minus 2 times x plus 1 is equal to natural log of 3x minus 5. So let's make the multiplication on the first side. So if we take x minus 2 times x plus 1, we do the multiplication distribution here, x squared minus 2x plus x minus 2. If we group it, x squared minus x minus 2. So back to our equation here now. We can rewrite natural log of x squared minus x minus 2 is equal to natural log of 3 times x minus 5. Now we take the exponential base e of both sides. We don't change anything, and we simplify, and we get x squared minus x minus 2 is equal to 3x minus 5. So we have to subtract 3x minus 5 from both sides. We get x squared minus x minus 2. So minus 3x minus 5 will be minus 3x plus 5 here. And we do the same thing on the other side. So we say is equal to the original one, 3x minus 5, minus the same value. So minus 3x minus minus 5 becomes plus 5. So the second part becomes 0 now. And we go and group on the first side. We get x squared minus x minus 3x minus 4x minus 2 plus 5 is plus 3 is equal to 0. So we have to find two numbers making the sum of negative 4 and the product of 3. To factor this one, we could use the delta, discriminant delta, to find the solution, but we don't need that. So sum of negative 4 and the product of 3, if we split the 4x into negative 3 and negative 1, the product is 3 and the sum is negative 4. So x squared minus 3x minus x plus 3 is equal to 0. So we factor here. So x factor in x minus 3 in the first part, minus 1 factor in x minus 3 on the second part here, gives us a 0. So we take out the factors, we get x minus 3 times x minus 1 is equal to 0. Okay, so this is what we have to solve now. And let's reproduce the same thing here. So to make these 0, any of the product can be 0. So when x minus 3 is equal to 0, that means x equal to 3 is one of the solution. We can mark that one number 1. and the other one is x is equal to 1. That makes the second one 0. And let's analyze this, because in case of logs, every time you find a solution, you have to make sure that these solutions are valid. Sometimes there are some surprises. So let's take the value of 3 and plug it in. So Neperian log of 3 minus 2 plus log Neperian of 3 plus 1 is it equal to log Neperian of 9 minus 5. So let's do the calculations. Log Neperian of 1 plus log Neperian of 4 is it equal to log Neperian of 4. But one thing we know, that log of 1 of any base is equal to 0. That means 3 is a solution here. Okay? So x is equal to 3 is one of the solutions. How about number 2? Let's take x is equal to 1 and plug it in. So we get Neperian log of 1 minus 2 plus log Neperian of 1 plus 1 is it equal to Neperian log of 3 minus 5. So we have two cases here where we have log Neperian of a negative number which does not exist. So that is not a solution. So we have to reject the solution of x equal to 1. So it's not valid. So we get finally final solution x is equal to 3 is our final solution. Thank you.